Yes, good morning students. Then in the previous class we already discussed that is what is structural isomerism, that is chain isomerism, position isomerism, functional isomerism, metamerism and then tatamerism. Chain isomerism means compound having same molecular formula but different type of chains. Position isomerism means compound having same molecular formula but different type of position, like multiple bond, that is triple bond, double bond, then the alcohol halogen positions will be changed. The next one, functional isomerism, compound having same molecular formula but different type of functional group are called functional isomer, and the study of phenomena is called functional isomerism. After that we already discussed what happened, metamerism. That metamerism nothing but compound having same molecular formula but different type of alkyl groups are called metamer, and the study of phenomena is called metamerism. After that, tatamerism we already discussed that what is the tatamerism, compound, there are two fundamental concepts. Compound should have at least one electron withdrawing group such as CO, Cn, NO2, and compound should have at least one acidic hydrogen and alpha carbon. If two fundamental is it is two concept that you can easily identify that which one is the tatamerism, which one is not formed. So that's why after that keto enol tatamerism is we already discussed. Then nitro to form acynitro, amine to form enamine. So what is then after that we already discussed elements of symmetry, that are what is the plane of symmetry, what is center of symmetry, what is symmetry, asymmetry. So we already discussed. Today we discuss asymmetric carbon, optical activity of compound having asymmetric carbon, optical activity compound having asymmetric carbon. Now here few calculation is there, that is calculation of number of optical isomer, calculation of number of optical isomer, number of optical isomer, number of optical isomers. So now calculations of number of optical isomer, here few formula is there, that is first one is optically active form. Here number of optical active form, number of optically active, number of optically active, that number of optically active A equal to 2 power n minus 1. Next one, enantiomer pair, enantiomer pair equal to A by 2. Racemic mixture, racemic mixture also A by 2. In this one, Miso compound equal to 0. So what condition is used for this formula? That means when, for example, take one, I am doing for this one of the problem. Here see, here I am doing for a few problems. C6H5, CHOH, and then CH3. That means the above compound cannot be divided into two identical half, So it is cannot be divided into two identical half. So and both end will be different. So now in case both end will be different, what is optically active? Now in this given formula n equal to 3. So n equal to 3 means number of optical active. I am writing optical active nothing but OA. OA equal to 2 power 3 minus 1. Simply n equal to 3. Simply n equal to small 2 power n. Number of optical active is 2 power n. A number of optical compound is what happened 2 power n. So that's way what is optical A equal to 2 power n. Now that's why n equal to 3 means 2 power 3. So number of optical active form is how much? 8. After that enantiomer pair. Enantiomer pair I am doing for EP stands for enantiomer pair. A equal to 8 nothing but enantiomer pair 8 by 2 is nothing but 4. Next one racemic mixture I am writing for RM. So it is also A by 2 nothing but 8 by 2 is nothing but 4. Then Miso. Miso here in this one Miso compound Miso is belongs to 0. This when is use this formula the two end will be different. It cannot be divided into two identical half. It cannot be divided into two identical half. So you have to use like this formula. Number of optical active A equal to 2 power n, enantiomer pair A by 2, racemic mixture A by 2, Miso is nothing but 0. So this is one. This is one type of formula. Now second formulas. So what is the second one? Same thing. It can be number of optical active. Second one number of optically active. Number of optically active A equal to 2 power n minus 1. The next one enantiomer pair that is A by 2. Racemic mixture is nothing but A by 2. Then Miso form is a small different. That number of Miso form is a small different, that is m equal to, this is m equal to 2 power n by 2 minus 1. 2 power n by 2, a small correction here, 2 by 2 n minus 1. Then total configuration equal to A plus m. Total configuration equal to A plus m. So this total configuration equal to A plus m. So now let us we discuss when what condition is used for this problem, which can be divided into two identical half, but which can be divided into two identical half. For example like this. Example for this one. So here CHOH simply COH. Now here example of this one. So what is the example of this one? Example, so like this one, COOH, CHOH, then COOH. This is what happened? This is an chiral carbon. This is chiral. That's way here n equal to 2. So number of optical active OA, number of optical active OA equal to 2 power 2 minus 1, that equal to 2 power 1 is nothing but 2. Enantiomer pair equal to 2 by 2 nothing but 1. Racemic mixture is also 2 by 2 equal to 1. Miso, so here Miso equal to 2 power n by 2 minus 1. Here 2 power 2 by 2 minus 1, 2 power 1 minus 1, nothing but 2 power 0, 2 power 0. The 2 power 0 nothing but, so in this one here this is Miso compound means 2 power n by 2 minus 1. So just a small correction here, 2 power n by 2 minus 1, nothing but 2 power 0, 2 power 0 equal to 1, 2 power 0 equal to 1. Now what happened here, total configuration. Now here total configuration equal to A plus M. A nothing but how much? 2. A equal to 2. 2 plus M nothing but Miso is 1. The total configuration is 3. This is what condition is used? It can be divided into two identical half. It can be divided into two identical half but even numbers. N equal to what happen? Even number. So number of optical active A equal to 2 power n minus 1. Enantiomer per A by 2. Racemic mixture A by 2. Miso formula M equal to 2 power n by 2 minus 1. Total configuration is optically active and Miso. So the best example of like this. Okay, the best example is like this one. So what is the difference between these two? It can be divided in, it cannot be divided into two identical half. It can be divided into two identical half but even number. The next one, third one is it can be divided into two identical half but odd numbers. But odd number, what is the formula for this one? So it can be divided into two identical half but odd numbers. So now here also same thing, few formulas is there, that is third one. So what is the, this is first one, this is first one, second one. Now I am doing for third one. It can be divided into two identical half but odd number. So first one what happened? Optically active, number of optically active, one type of formula. Enantiomer pair, another type of formula. Racemic mixture, one. Then what happened? Miso, it is also one type of formula. Total configuration. So this total configuration nothing but A plus M. So what is number of optical active? That nothing but A equal to 2 power n minus 1. So now here also A equal to 2 power n minus 1, but here a small change for this one, minus 2 power n minus 1 by 2. Enantiomer pair what happened? A by 2. Racemic mixture also A by 2. This is no problem. But here Miso is a small difference. M equal to Miso, M equal to 2 power n minus 1 by 2. Now this is the for what happened? It can be divided into, it cannot be divided into identical half. It can be divided into identical half. It can be divided into two identical half but odd numbers. But what happened? Odd number. Now how do that calculation on based on this problem? How do that calculate based on that problem? See, for example, so here it can be divided into identical of nothing but see, for example, like this problem here COOH, this is the problem, COOH and CHCl, CHBr, CHOH, then CHBr, HCl, then COOH. So this it can be divided into, it cannot be divided into identical half, but this is 1, 2, so this is, it can be, what is the formula for this one? It can be divided into two identical half, but what happen? Odd numbers is there. That means here n equal to 5. So what is the formula of this one? In this one, so both end will be same, both end will be same. So like this, COOH, CHCl, CHBr, CHOH, CHBr, CHCl, COOH. Now it can be divided into two identical half, but n equal to, there are 5, n equal to, this is one chiral, this one 2, 3, 4, 5, that's why n equal to 5, that's why n equal to 5. Number of optical active, now here formula, number of optical active, number of optical active, then now A equal to 2 power n minus 1 minus 2 power n minus 1 by 2. So that's why n equal to 3 means A equal to 2 power 5 minus 1 minus 2 power 5 minus 1 by 2. That's why 2 power 4 minus 2 power 4 by 2, that equal to 2 power 4 minus 2 power 3. So 2 power 4 minus 2 power 3, nothing but what happened? So this is a 2 power 4, nothing but 16. 2 power 8, nothing but 8. So number of isomer is what happened? Number of isomerism is this is 2 power 2, a small correction, sorry. So now in this one what happened? This is 2 power 4, nothing but 16, a 2 ones, 2 2s, nothing but 4. 4 minus 16 minus 4 equal to what happened? 2. Enantiomer pair. Enantiomer pair equal to A by 2 is nothing but 12 by 2 equal to 6. Racemic mixture is also A by 2, nothing but 12 by 2 is equal to 6. Next one, Miso form. What is the Miso form? M equal to 2 power n minus 1 by 2, that equal to 2 power 5 minus 1 by 2. So 2 power 4 by 2 equal to 2 power 2 is nothing but 4. Then total configuration, this total configuration equal to A plus M. The total A nothing but what is 2, 12 plus 4 equal to 16. This is what happened? Optical active compound having asymmetric carbon, that based on calculation of number of optical isomer. So it is what happened? It can be divided into two identical half, but odd number. So number of optical active equal to 2 power n minus 1 minus 2 power n minus 1 by 2. Enantiomer pair A by 2, racemic mixture A by 2, Miso M equal to 2 power n minus 1 by 2. Total configuration is M. Total configuration is A plus M. Now in this one n equal to 1, 2, 3, 4, 5. Both end will be same, but it can be divided into two identical half. That's why n equal to 5. So number of optical isomerism is 12, enantiomer pair A by 2 6, racemic mixture A by 2 6, Miso compound is 4, total configuration is A plus M nothing but 16. So this is what is asymmetric carbon. Next one, this optical active compound containing one asymmetric carbon. How to do that one asymmetric carbon? Very interesting concept. One asymmetric carbon. Now after one asymmetric carbon, optical active compound having two asymmetric carbon. How do the calculations of that? Now, so this is optical activity compound containing one asymmetric carbon, optical active compound containing one asymmetric carbon. Now same thing here, one asymmetric carbon, here one asymmetric carbon. Next topic is goes to one asymmetric carbon. So optical active compound having one asymmetric carbon, what is the one asymmetric carbon, how to identify, what is the enantiomer, what is diastereomers. So now we discuss. So that is next concept is optical active compound having one asymmetric carbon, one asymmetric carbon. Right. Okay, this optical active compound having one asymmetric carbon. Now discuss. So now I am doing for next heading. What is optical active of compound containing one asymmetric carbon? Optical. Next topic is goes to optical active compound. Optical active compound containing one asymmetric carbon, one asymmetric carbon, one asymmetric carbon. So what is this one asymmetric carbon? Now let us we discuss. For example, here both end will be same. So this is one asymmetric carbon. Here few examples of this one. Examples. Okay, CH3, CHOH, CH3, CHOH, and then last one is COOH. This is one asymmetric carbon. One asymmetric carbon. Next one, see second example, CH3, CHOH, then CHO. This is one asymmetric carbon. Next one, CH2OH, CH2OH, CHOH, then CHO. This is one asymmetric carbon. Next one, C6H5, CHOH, then CH3. This is one asymmetric carbon. So that means optical active compound containing one asymmetric carbon. This is one asymmetric, one asymmetric, one asymmetric, one asymmetric. For example, if you see like this, that means if you see like this, what we observe here COOH, here CHOH, then C, this is last one only CH3, this is CH3. Now which is mirror image to each other? Mirror image. So what happens? C, this side OH, here H, this side COOH, this side CH3. So this is 1, this is 2. 1 and 2 both are mirror image to each other. 1 and 2 both are mirror image to each other, that are called both are, this is 1 and 2 both are mirror image to each other, that are called enantiomer pair, that are called enantiomer pair. That means here one molecule having asymmetric carbon contain two configurations, one molecule having asymmetric carbon containing two configuration. The two configurations are 1 and 2 are both are mirror image to each other, are called what happen? Enantiomer pairs. Now after this, that means this is one asymmetric carbon. Next one, optical activity compound containing two chiral carbon atom, two chiral carbon atom. Next one, optical active compound containing optical active compound, optical to compound containing 2 chiral carbon, 2 chiral carbons. So, what or 2 chiral atoms, optical active compound containing 2 chiral atoms. Okay. Now, see what is the meaning of this one? 2 chiral atoms, nothing but, for example, when molecules not divided into 2 identical half, these are case 1. When molecule is not divided into 2 identical half, when molecule is not divisible by 2 identical halves. So, this is. So, that means what happened? Now, let us one example for this one. Here, this is case 1. See, it can be divided into 2. For example, this is COH, this is Br, and this is C, this is H, this side Br, and this side C6H5. It is not plane of symmetry. It is not a plane of symmetry. That's why it is not divided into identical half. But which is mirror image? It is mirror to get like this. COOH, C here H, sorry. So, if mirror image to each other, what happen? A little bit, if this is on mirror image, this is mirror. So, what happen? This one COOH, this side C, this side Br, this side H, this side C, this side Br, this side H, this side C6H5. So, this is one structure, this is second structure. Okay. Now, one more example for this one. Here I am doing for different example. Here COOH, this side H, C, this side H, this side Br, this side C, this side Br, this side H, this side C6H5. This is third structure. Now, if mirror image, what happened in the mirror image? So, now which is mirror image to each other? This is mirror. So, what is COOH, then C here side Br, here side H, C this side H, this side Br, this side C6H5. So, this is what happened fourth. So, here there are, that means when molecule is not divisible into identical half, to get what happened? This is one molecule is cannot be divided to it is not divided into identical half due to in the top place carboxylic acid, bottom place COH, C6H5. So, that is why it cannot be divided into identical half. How many product is formed? 4 product is formed. Now, in this one here 1 and just you have to observe this one. Here 3 and 4, 1 and 2, 1 simply 1 and 2 and 3 and 4, 1 and 2, 3 and 4 are enantiomer pairs, enantiomer. But in this one 1 3 3 4 are resume mixture, 1 3 and 3 4, 1 3 and 3 4, 1 and 3, 1 and 3 and 3 and 4, 3 and 4 are racemic mixture. So, this is in this equation 1 and 2 which are mirror image to each other, 3 and 4 which are mirror image to each other, that are called enantiomer pair. So, now in this example I am doing for a very interesting concept here. See, this is very important. In this one 1 and 2 are diastereomers. 1 and 2. 1 and 2 are diastereomers. Diastereomers. Okay. Next one, all contain 1 and 2, 2 and 3. Here 2 and 3. After that 1 and 4. 1 and 4. After that 2 and 4. 2 and 4. These are contain diastereomers. Diastereomers. Stereomers. It is also diastereomers. Diastereomers. It is also same thing. That means here 1 and 2. It is 1 and 2 are diastereomers. 2 and 3 are diastereomers. 1 and 4 are diastereomers. 2 and 4 also diastereomers. So in that example, this is 1 and 3. It is 1 and 3. 1 and 3 are that 1 and 2 are enantiomer pairs. 1 and 2 are which one is the mirror image to each other, that are called enantiomer pairs. Which one is not mirror image to each other, which is not mirror image, this one, it is not mirror image to each other, that is why diastereomers. 2 and 3, it is also not mirror image to each other, that is why diastereomers. 1 and 4, it is diastereomers. 2 and 4 also not a diastereomers. So this is one of the concept. Next after that, so this is what is optical active compound containing one asymmetric carbon. So this is one asymmetric carbon, here one asymmetric carbon. If mirror image to each other, these two are what happen, 1 and 2 are mirror image to each other. That is why this is enantiomer pairs. Now optical active compound containing 2 chiral atoms. So this is 1, 2 chiral atoms. 1 and 2 chiral atom, it will be contain 4 compound, 1 and 3 diastereomers, 1 and 2 are enantiomer, 1 and 3 are diastereomers, and 1 and 4 are diastereomers, 2 and 3 are diastereomers, 2 and 4 also diastereomers, but 3 and 4 are enantiomers, 3 and 4 are enantiomers. So now here like this, 1 and 2, 1 and 2, 1 and 2 and 3 and 4 are enantiomers, That enantiomer means which both are mirror image to each other. Next, so this is case 1. What is the case 2? When molecule, now this is case 1, now case 2. So what is case 2? Here when molecule is divided into 2 identical half, case 2, when molecule, this is case 2, when molecule is divided into 2 identical half, when molecule is divisible into 2 identical half, divided into 2 identical halves. So now, so it is cannot be divided into identical halves. Now molecule into divided into identical half, what is the meaning of this one? See, it is nothing but, so this is the formula. So this is COOH. Now this side C, this side H, and this side OH, and this side C, this side OH, this side H, and this side COOH. This is one. What is the mirror image of this one? If mirror image, this is COOH, then C, this side OH, this side H, this side C, this side H, this side OH, and this side what happened? COOH. And this is, of course, this is one structure, this is second one. What is the third one? This is COOH, then C, this is H, this is OH, this is C, this is H, this side OH, and this is COOH. Okay. Now, so this is third structure. what we observed in the star structure, here I am writing for one small, 1 and 2 are enantiomer. So, that means 1 and 2 are enantiomer, 1 and 2, 1 and 2 are enantiomer, enantiomer. Next one, 1 and 3, 1 and 3 are diastereomers, 1 and 3, 1 and 3 are diastereomers, diastereomers. But third structure is only form meso, third structure is only form meso. That means this third structure is optically inactive, this is optically inactive, optically inactive of the optical inactive, optically inactive, it is meso compound. So, what happened in this structure, 1 and 3, 1 and 2 are enantiomer, that means these are mirror image to each other, 1 and 2 are enantiomer, 1 and 3 are diastereomers, but 2 and 3 it is also not diastereomers, but only third structure is meso compound. That means what is meso? Next I am doing for meso compound, it is meso nothing but last two concept is Miso form. Last concept what happened? Miso form. What is the meso? The two hydrogen atoms are which are this is COOH and this is C, this side H, this side OH, this side C, this side H, this side OH, this side COOH. It can be identical into two identical half and the two hydrogens are in same inside and the two hydrogens are in same inside, the two hydrogens are in same inside, is called meso, is called meso compound. So, this is meso and it is plane of symmetry and it is plane of symmetry, plane of symmetry and it is a plane of symmetry. So, that means this is what happened, asymmetric carbon. So, what is asymmetric carbon? Optical active compound having asymmetric carbon, that is which there are which can be divided, it cannot be divided into identical half. What is optical active, what is enantiomer pair, what is residue mixture, what is meso, and it can be divided into identical half. Next to case 1, case 2. After that, optical active compound contain 2 chiral when molecule having divided into identical half. This one 1 and 3 diastereomers, 1 and 4 diastereomers, 2 and 3 diastereomers, but 1 and 2 enantiomers, 2, 3 and 4 enantiomers. So, when molecule is divisible into identical half, so it is it's not plane of symmetry, but it can be divided. So, it is plane of mirror image. 1 and 2 are enantiomer, 1 and 3 are diastereomer, but third structure is what happened, meso compound. So, what is meso? That whose meso compound is optical inactive and that is a plane of symmetry. So, this is what is symmetry of molecule. So, this is symmetry of molecule. So, this is what is asymmetric, what is symmetric, what is chiral, how to calculate calculations of asymmetric carbon we already. So, this is today topic, to be next topic to be continue on next class.